What's going on, everybody? It's Kistner, and today we are studying Section 5-3 or Section 5.3 out of your book in your student companion. It'll be around page 122. It's called Graphing Radical Functions. So today it's all about graphing. We're going to use our calculators a little bit. We're going to do just some basic math in our heads and plot some points, and we're going to get some new graphs. So let's get into this because it's important to know what these graphs look like. So example 1 should be around page 122 in your student companion. It says, graph the following function. What are the domain and range of the function, and is the function increasing or decreasing? So we're studying this example is graph, square root, and cube root functions. So we're going to have a square root function here, and part B is going to be a cube root function. So let's look at what a square root function looks like. It's kind of a strange looking function. But in order to do that, I'm going to think. I realize that I'm going to have to take the square root of things. So I'm going to plug in points for x that when I subtract 5 from them, I get a perfect square. So for example, if I plug in 5 minus 5 is 0, and the square root of 0 is 0. So see, the square root of 0, I know that. So 5, 0 is a point. Go ahead and put that point down here, 5, 0. For example, if I plug in negative 1, I get negative 1 minus 5. And the square root of that is the square root of negative 6, which is imaginary, and I can't graph it. So I can't plug anything in. Can I plug anything in below 5? Let's see. Can I plug in? I'll make it a little bit easier to see here. If I plug in 4 minus 5, that's going to give me negative 1, and that's an imaginary number. Square root of that is an imaginary number. So I can't plug in anything below 5 on the x-axis, which should give you a hint of your domain. Now, what happens if I plug in 6? If I plug in 6, 6 minus 5 is 1. The square root of 1 is 1. I can graph that. 6, 1 is a point. So it looks kind of like a straight line right now. 7 would give me 2, and that's not a, I don't know the square root of 2. Square root of 2 is not a real round number, so I can't really see that one too much. Plug in 8, that would give me 3. 8 minus 5 is 3. I don't know the square root of 3. Plug in 9, and I get 4. 9 minus 5, sorry, that's not right. 9 minus 5 is 4. Square root of 4 is 2. 9, 2. So 9, 2. So it's not a straight line. What it is kind of a sideways parabola. And actually, that's exactly what it is. It's a sideways parabola. Okay? So we need to answer a few questions. The domain. So what makes this become imaginary is what I'm thinking. What can I not take the square root of? I cannot take the square root of negative numbers. Well, what's the first negative number I can get out of this? Well, 5 gave me 0, so anything below 5 is going to give me a negative number. So I'm going to say domain is x such that x is greater than or equal to 5. Okay, x is greater than or equal to 5. The range will be y's that are such that y is greater than or equal to 0, because it never is going to come back this way. It's always going to stay up here. Okay, it's always going to stay up. It's never going to drop below the x-axis. Okay, another way to write this would simply be just x is greater than 5 and y is greater than or equal to 0. X is greater than or equal to 5. Your book uses these. I've just been taught to use these, so that's my default. Now we'll do part B in class. That one gets a little bit more tricky with the cube root, but we'll do that one in class. Okay, example, I skipped one there. Example 2. Graph g of x. What transformations of the graph of the original f of x produce this graph? What is the effect on the transformations of the domain and range? Okay, so we have a lot of questions to answer here. So let's first off graph this. The square root of x, if we just plug in the points, so 0, 0 is a point. I'm going to make the f of x red. Okay. 0, 0, if I plug in a 1 for x, I get 1. If I plug in a 4 for x, I get 2. If I plug in a 9 for x, I get 3. So you get to see more of the function here. Okay, so that's 114293. Square root of 9 is 3. Okay, and we'll discuss later why we don't go ahead and say the square root of 1 is also negative 1. The square root of 4 is also negative 2. We don't do that, and we'll discuss later why that is. But let's start moving this thing around. Okay, so what happens with the negative 1 and the negative 3? Well, we should know what that is. The negative 1 is going to be, it's grouped with the x, so it's going to be right 1, and the negative 3 is going to be down 3. The 1/2, well, that's just going to multiply all of these numbers by 1/2. So I'm going to do the 1/2 thing first. So if I plug in just 1/2 the square root of x. Let's just do that for a second. 1/2 the square root of x, and I'll make that blue here. If I plug in 1/2 the square root of 1, I get 1/2. So when I plug in 1, I get 1/2. Plug in 1, I get 1/2. So it should be here. Plug in 4, I get 1. Plug in 4, I get 1. So what it's doing is it's cutting all of these in half. It's shrinking them down by half. This was at 3. It's going to end up being at 1.5. Okay, because the 1/2 times the square root of 9, square root of 9 is 3. That's 3/2, or 1.5. So this blue thing now is what I'm transforming. Flatten it out by a degree of half, and I missed that point, but it should be like that. So I just have to move this blue thing right 1 down 3. So if I do that, I move it right 1 down 3. Oh, let's change colors. I'm going to make this one, let's make it orange. Right 1 down 3. There's the origin point. This one goes right 1 down 3, up to a half from that. Right 1 down 3 from here. Right 1 down 3. There. So we get this weird looking graph. But really what I did is I just shifted every single point right 1 down 3 and cut it in half. So instead of it being 1, 1, I shift it right 1, it becomes 2. Down 3, it becomes negative 2. Multiply it times a half, and you get that. Okay? So it's kind of a weird process. But the easiest thing to do is to do your stretch or shrink first, this right here first, and then move those points right 1 down 3. All right, so let's look at example 3. What transformations of the parent graph produce the following graphs? Okay, so this is where knowing the general form of a square root function comes in handy. So f of x, and this is something you probably need to know, is going to be a, the square root of x minus h plus k. That hasn't changed. That's like our parabola. You know, the vertex form of a parabola, a equals x minus h squared or whatever, plus k. Now, or y equals a times that. Now, so we need to make this function look like that. So right now I don't have an a, I do have a k, and it looks like something like I have an h, but really I have something in front of the x, which is a 7. So when I rewrite this, I get f of x equals, and I don't have an a yet, so I'm going to leave it. I'm just going to rewrite this for a second. 7x minus 3.5, and that minus 10's all the way out here. So here k is a negative 10. We know that already. I need to know what a is, and I need to know what h is, because those are my vertical stretches, transformations. If I can label all of these, I know what my transformations are. So what I notice is this 7 in front of my x. I can't have that. There is no number in front of the x on the original, this green function, so I can't have it here. So I'm going to factor that 7 out. That was ugly. Let me do that again. So if I factor the 7 out inside here, I'm left with x minus 0.5. Okay, you can do the math there. 7 times 0.5 is negative 3.5, and it's still minus 10. So our rules of radicals that we learned last time tell me I can separate it like this. Square root of 7 times the square root of x minus 5, or 0.5, and then it's all minus 10. So that answers everything. Look at what we have. A, the root of 7 is where that should be. That goes there. My h is 0.5, because it's supposed to be minus. Remember, it's always opposite, so 0.5. So the transformations are, we went a vertical stretch. We can say vertical stretch of square root of 7, whatever number that happens to be right there in between 2 and 3. Shift right 0.5 and down 10. And we're done. Vertical stretch of square root of 7, shift right 0.5 and down 10, or shift right 1/2. I got all that because I factored everything out and wrote it in y equals a times the square root of x minus h plus k. Just found the generic form. You need to know this general form, because if you can put them into that form, you can write the vertical and horizontal transformations. We'll do part B in class. So this is a strange one. These are more like puzzles. It's telling you it's a radical function. What is represented below? Now, you should recognize part A. That's all we're going to look at today in this video, is part A as being a square root function. Being a square root function. Okay? Now, I always like to find, so I know my parent function is f of x equals the square root of x. So I'm going to go ahead and graph that. 0, 0, 1, 1, 4, 2. Oh, that's way off. Hold on. 0, 0, 1, 1, because it goes up by 2, 4, 6. It goes up by 2s. It's here. And then 2, 4, 2. 4, 2 would be here. You got to be careful because this is going up by 1s, but left and right by 2s. It's kind of weird. So we're going to go, out 1, up 1. Out 4, up 2. There we go. Out 9, up 3. So that's my function. This is my original f of x. And I just got to move it and figure out if it's stretched at all. So I can tell right here that this point and this point match up. Okay? So what that tells me is it's been moved, looks like it's been moved left 5. This is at 0, 0. It's been moved left 5. So I know that I got to go left 5, which in my book is x plus 5. Right? Because remember, when you're in parentheses, you do the opposite. And how has it been moved down? This point is at 0, 0. It's been moved down to 4. So it's going to be down 4, which is just a minus 4 on the outside. All right, so let's see if it's been stretched any. So it should go out 4, up 2. If it goes right 4, it should be at negative 1. And if it should go up 2, it should be at negative 2. So it hasn't been stretched at all, because it went out 4, up 2, and this one went out 4, up 2. Those are the same. So it hasn't been stretched at all. So that's a pretty easy function to write. So my new function, I'm going to call it h of x. Doesn't really matter what you call it. H of x equals the square root of, because I know that's the general shape, and I use my shifts. X plus 5 minus 4. And there's my answer. Well, we haven't learned what part B is yet. We'll do that in class. So what you need to do is you need to go back and re-watch this video, because it was kind of a long one if you didn't quite get it. Go ahead and re-watch it. Make sure you're prepared for class tomorrow, and I will answer a lot of questions that you might have in class next time I see you guys. You have a great day, and this is Kistner out.